So we're going to just talk together for a minute, and then we're going to take some questions from the audience. But a lot of you talked about training and education, and I'm curious your thoughts, and you could just answer it in a word or two. How early is too early? Are we talking about, Jamy, you starting to educate your medical students about systems, or are we talking about kindergarten? What do we envision for the next generation in the years to come in terms of really fostering systems thinking across the population? So maybe I'll start with you, Jamy. How early is too early? Oh, you're on mute.
All right, so we're manually muting and unmuting. Okay. I don't think any age is too early. I think it's just a way to organize the interactions that we have. And we don't necessarily call it systems thinking when we're talking to our, 3-year-old or teenagers, but everybody is starting to understand the interconnectedness of the world that we live in. If I don't wear a mask, then it has an impact on the people who I live with and the people I work with. And that has an impact on their ability to earn a living. And then the economy is affected at a larger level. So there's a domino effect, and we call it different things, but what we're talking about in the nomenclature we're using is systems modeling. But I think no age is too early.
Yeah. Anybody else want to comment on that?
There's a wonderful book. It's a systems thinking book, and it's like kind of a primer. And I think the first sentence of it is, a tree is a system, a human body is a system. And so when you start thinking about, I think it was Doug on one of our prior conversations who's talking about like the terminology that modelers use and the terminology that system scientists use can sometimes feel intimidating, but it actually is just describing something that already sort of innately understandable by the human brain. I think if you sort of conceptualize it like that, and I know there's also a wonderful person who writes children's books. Like she is actually like a researcher who does system science modeling, but she also writes children's books. And one of her books is about how like the flap of a butterfly's wing like created this entire downstream effect, and it's a children's book. And so I agree with Jamy. I don't think that I think you can start sort of introducing that methodology of thinking at a very, very young age.
Yeah, great.
Just to add to that, what Stella said, I suspect we actually get trained out of systems thinking as we grow up. In particular, the way that we get training in the natural sciences is often very systems focused. But when, for people who end up in the social or health sciences, we learn that, statistical models are the only way to sort of view the world. So I think systems thinking, it's never too soon. And it's really about encouraging that way of viewing the world all along until they get to grad school.
Yeah.
I think another perspective on this is that sometimes we may have to just call it out when it's not necessarily called out for us. That for example, Jamy, in your response earlier, you indicated that systems thinking ought to be part of medical training, but really fundamentally biology and medicine are systems thinking kind of fields. And so calling it out when it is what it is useful too. And that can happen at any stage of life. It can be in the context of play, in the context of training or education as well.
And there can be too much of a separation between the methodology and the thinking and content, et cetera. Like, for instance, you wouldn't, if you were to learn carpentry, you wouldn't have a single course on hammers. Like, here's a hammer and how you use a hammer. Similarly, you don't say, I've heard people say, I want to build an agent-based model. And you say, why? No, I just want to build an agent-based model. Then I'll figure out why. That's really not what these methods or approaches are for. They really should be just more integrated with everything else.
Yeah, absolutely.
Yeah, go ahead, Chris.
No, please.
No, I just wanted to extend on what Bruce was saying in terms of the sort of like partitioning out, and to sort of remind the audience, like we have done we've done a great job in terms of selecting a particular example to illustrate the application of system science, right? But there's a lot of system science and there's a lot of modeling and there's a lot of simulation modeling that happens in a vacuum, right? And so there'll be all these wonderful, beautiful models that talk about the benefits of tax or the benefits of health incentives or, SNAP or SNAP participation, but then there's no kind of comment about the actual real world implementation of it, the costs associated with it, the sort of headaches and the loopholes and the hoops you have to jump through to kind of get those things implemented. And so I kind of want to just put in a sort of card for that as well, that I think that there is a big value to having it be multi-sector and having it be, something that is not just happening, just like clinical trials, right? Like in some ways they're very ivory tower and they're vacuum. And then when you bring them into the real world, you have to distinguish between efficacy and effectiveness. Well, participatory system science and system science modeling is no different. You really want that, element of participation so that it can be applicable and helpful and sustainable in the long term.
I just
go ahead, Sara.
Yeah, just very quickly that I think some of it has to do with the way we have structured some of our educational programs. And I know this is a difficult question, but they have become so siloed that people, especially in some of the engineering fields and other fields, that there is not enough exposure to other disciplines and other ways of thinking. And I know many universities are struggling with that. And it shouldn't just be at the university level. I think we have to start addressing those questions at much younger educational levels.
Yeah, I agree. When I've seen high schools do a capstone project or some sort of a, interdisciplinary project, it can be not just eye-opening, but life-changing for those students. And having them go on and study something they didn't think they would, or address a problem that they didn't think they were capable of thinking about. So very useful. Were you going to jump in, Daniel? Yes.
Yeah, I just wanted to just briefly mention that, I'm teaching 150 seniors this semester in process control and things like that. And I like bringing in the examples from things that I have learned through the research and things that would not be considered traditional chemical engineering. And what I find is that even with students that are trained and have a lot of mathematical skill, you still have to work on their systems thinking. Okay, and get them to not approach everything as a detailed math problem. And actually, and in fact, sometimes you get resistance. You say, well, what I want here is I want an informative sketch from this model and to build intuition that way. And because their natural tendency is just to treat everything very formally. And but that's not systems thinking in my book.
Mm-hmm. Yeah. So we do have a few, we have some questions from the audience. If it's okay, I'm going to put them out there and see. So
I was going to add something, but.
To that, please, go ahead, David.
Okay, thank you. So I think that we should be aware of the difference between system thinking and systems modeling. Yeah. So the system thinking, I think it should be present throughout the education since very early age. And there are two components to that. One is, so people start to understand about processes. So how some actions, generate some flow in certain processes in certain systems, and then they generate an output. So getting that input, process, output, I think is important since a very early age. So people, start thinking about outcomes and stuff like that. So the second thing is the interconnectivity. So learning system thinking that, if you are solving a problem, that problem is likely to be affected by many other things in the environment that you didn't think they were related directly in the problem. So those two things, processes and interconnectivity, and having that big picture, is important. So I think even right now, the Association of the School of Public Health for accreditation into the Masters in Public Health requires that competency. It's explicitly said complex systems, system thinking is, a competency that you need to demonstrate that your student have. We don't need to wait for a master's program to get there, right? That should be coming much earlier. Now, when you're talking about implementing some models out of the system thinking, I think that requires some more formal background and training. So it's not to, I've seen, some individuals that, I understand the system, it's just technicalities what we need to do, or think that they are, going to translate that mind map or that explicit map into something actionable in formal way. That requires a little bit more training or more, certain maturity in certain disciplines, and then you cannot become that kind of a person, that model, without having the system thinking approach and learning how to focus problem. But you need that special training, I think, after the fact, or come from and acquire somehow, and that's a specialization there. And I would, it's important. I think we learn to define and distinguish both.
Right, absolutely. And just to illustrate, I think many of us are from really different disciplines, and yet we're all systems thinkers, and some people are doing the modeling on top of that with more specific training. So we have a couple of questions, and maybe we can get to both of them if we limit the discussion to just a couple of minutes on each. The first one is pretty specific. Have any of the models examined policies which include taxation of sugar-sweetened beverages on consumption and ultimately the impact on incidence of obesity? So anyone have thoughts on that or experience?
The very short answer is yes.
Good.
Period. The slightly longer answer is yes. Yes. And for instance, our GOPC issued a pilot project to researchers in University of California, Berkeley, where they were collecting data on the SSB taxes that were being implemented in the different municipalities in the Bay Area. And then the goal was then to use some of this data to help calibrate and also validate different models predicting what might happen with implementation of the SSB taxes. It is a complicated issue, of course, because accompanying the SSB tax implementation was also a lot of fanfare. You heard about this in the media. So then the question is, did that actually influence also SSB consumption as well? So there are ongoing efforts to really look at these issues.
Great. And does anyone else have any thoughts on this question? Okay, great. So the next one is, for someone who does not know much about systems modeling but appreciates its utility, how does one begin working with the approach? Who can I turn to in getting a kickstart to facilitate the process? So we don't know if this is from a practitioner or someone still in training. So maybe from a couple different perspectives, we could hear some thoughts.
One quick thought is to ask this question to Patty, who's coming up. Patty may have done more than anybody else to respond to the gap in training and education in these methods. So I'd love to hear her thoughts, 10 years later, as it were. This is still a place where very few places have training in all of these methods at one place. So social networking is required, finding out who locally does this work, starting with the people who've been involved in all of the workshops and presentations that you've sponsored would be a really good way. And I'm sure other people have better recommendations. I
would recommend using what I call the happy hour approach. So if you're walking into a happy hour and you know no one or nothing, then you try to identify someone who has crossover interests or has experience working with someone like you or interacting with someone like you, because what you don't want to do is try to approach someone who's like exclusively completely in another field and has absolutely no crossover and understanding in terms of what you do. So if you can identify someone who has experience in that area and really can bridge the gaps between systems modeling and your interests and your policy work or whatever you're doing, that actually works even better.
What I would just mention briefly is that for those who are in academia and are interested in maybe working with engineers who might have relevant skills, maybe a message to the Dean of Research for the College of Engineering, just saying, hey, is there, because there are a lot of people in my discipline, and not just chemical, mechanical, electrical. And I would say that, whereas, 15 or so years ago when I first got started, the idea of working with problems that involve human behavior was sort of considered to be very different. Now I think there's a lot more understanding that these are interesting problems. So maybe, some kind of, notice to a dean of a research dean might bring some folks at your university that could be people to talk to.
Great. So there is one more question that I think is a really important one. We have a couple more minutes, and the question is that part of the pushback against treating obesity is using weight status to assess health. So could anyone speak about whether the definition of this key health issue in developing systems modeling can result in unintended consequences? So can it really increase stigma or influence mental health or disordered eating? And if that's the case, how would we address it? How would we avoid that? Dealing with the fact that health is an issue and it's related to weight, but yet we don't want to create an unintended consequence.
I guess I can offer.
Maybe a somewhat.
Yeah.
No, go, Bruce. You can go ahead.
Yeah. So this is one of the challenges. When you do systems modeling and you build a model, you're actually incorporating all these different factors and processes into play. So there's rarely one thing alone like weight that drives everything. The challenge, though, is many times when these models and the results are translated, like to the public or policymakers, it doesn't always reflect the actual complexity that went into the model. And so you can have things like that. You can have, you might see an announcement that just says, this model shows that weight is associated with these bad health outcomes, et cetera, which is really not telling the whole story. So I think, as a community, we all need to work better at really translating. We could have a whole workshop on this, on how do you actually translate systems thinking and systems modeling results then to the public, because you don't want it in the same situation where, you have these headlines, there's some like broad cohort epidemiology studies that show, coffee helps you live longer, or coffee on the flip side, is bad and gives you this disease. We don't want those type of headlines because that's overlooking the complexity. So we need to find better ways of translating it.
Yeah, so we're going to have to stop this conversation, but not without thanks to all of you for your time today, for your incredible perspectives and all the work that went into planning the workshop today. Thank you on behalf of everyone at the roundtable, and I hope you have a great day.